We'll go ahead and look at a Statkey tutorial for generating side-by-side box plots. Since this is not our first Statkey tutorial and the instructions should be enough to get you through this whole thing, I would recommend trying it on your own just from the written instructions first, and then coming back to the video if there's something that you need help finding. I'll go through it fairly quickly on the assumption that you would just come through looking for the bits and pieces that you need and pause it to try it yourself. So that said, the first comparison we're going to look at is years in Austin by tattoos. Years in Austin is our quantitative variable. Tattoos is our categorical variable. So coming over to Blackboard, I am going to scroll down to my Datasets link. And in Datasets, find that Student Demographic Survey Results dataset. This is it right here. Right-click on that and choose Download. So I download this, save file, don't open, and in most cases this will go directly to your Downloads folder. Next, I would come over to Statkey to the home screen and go to one quantitative and one categorical variable, and then upload that file using the Upload File button and browsing for the file that you just downloaded on your hard drive. This screen comes up. I have to choose my quantitative variable first and my categorical variable second. That's how Statkey knows whether to treat the variable as quantitative or categorical. As we've seen, some categorical variables are still stored as numbers, so Statkey can't necessarily tell from the values whether something is quantitative or categorical. I'll choose years in Austin first because that's my quantitative variable, and tattoos second because that's my categorical variable, and hit OK. The side-by-side the side-by-side dot plot is often a little too sparse to really be able to see good information on, so I'm going to click on the Boxplot tab in my display to bring up these box plots. The box plot for my body is covered in them is just a single bar because we only had one observation in that category, so the whole box plot is just one value. Comparing these, one thing to keep in mind is that these categories are not necessarily ordered the way we would order them. My body is covered in them is on top, several or a few large is next, but then none comes before one or two small in this particular display, and yours may not look exactly the same as mine. And actually your boxes may look a little bit different also because this is one of those data sets that changes each semester. So the fact that none really should be on the bottom here, if we're going to think of this as an ordered box plot, means that we're not necessarily seeing a really strong trend here in years spent in Austin grouped by tattoos. So it doesn't seem to be the case that spending more time in Austin results in more tattoos or fewer tattoos. The next comparison that we are suggested to look at is siblings by tablet. The idea here is that maybe people with a lot of siblings are more likely to use a tablet as their main computer because parents of an only child or of just two children might be a little bit more likely to buy the computer for each child. We don't need to upload the file again for this. Just click on Change Columns and again choose your quantitative variable first and your categorical variable second. It tells you right up here at the top which one to select first. Then hit OK. It comes back to the dot plot again, so I would revert to the box plot. And in this particular data set, it does look like it is a little bit more common to use that, or rather, if it's a sorry, The number of siblings tends to be higher among those who use a tablet as their main computer. You could phrase it in the other direction. It does seem to be a little bit more common to use a tablet as your main computer if you have more siblings. Finally, we're going to look at shoe by gender. So shoe size is my quantitative variable, gender is my categorical variable, and it looks like not too surprising that there is a big difference here, that males tend to wear a larger shoe size than females, even though the sizes themselves are already adjusted for gender. So go ahead and try a few more comparisons of a quantitative and a categorical variable from this data set. See if you find anything interesting. While we're on this graph though, I'm going to look at these outliers. I can see in this data set I have a size 16 shoe for males. I'm going to look at my data set and see if that corresponds to an unusually tall person. So coming back to Blackboard and again coming back to data sets, this is where I came when I downloaded the student demographic survey results. I'm just going to double click on it now instead of downloading it, and it opens it up in a Google Sheet viewer. So if I come over to shoe and scroll down a bit until I find that 16, here is my 16 shoe size. And actually it's a little bit hard to see the whole thing in this view. I'm going to want to see the height of that person. I have to scroll back up to see the headings. Height is right next to shoe, so I can see that that is a 78-inch tall person, which is 6'6". So that does seem to go together. That might be something I would use as a check if I were concerned that somebody might have entered the wrong shoe size, for example. Since you've already downloaded the dataset, it's also possible to go find that CSV file and double click on it. If you have a spreadsheet program installed on your computer like Excel, by default it will probably open in your spreadsheet program, and you'll have a little bit more control there than we have in this Google viewer. But this is one way that we can examine the whole data set easily without having to get into other programs.